July 19, 2024. At 4:09 UTC, CrowdStrike's Falcon sensor distributed channel file 291 to approximately 8.5 million windows and points simultaneously. Within seconds, each machine attempted to read a 21st input parameter that the kernel's content interpreter had never been written to handle. The out-of-bounds memory read was unrecoverable at ring 0. The cascade cost $10 billion. The CrowdStrike incident is not a cautionary tale about one vendor. It is structural proof that probabilistic, best-effort software delivery is incompatible with kernel-level privilege. When a configuration file carries more fields than the interpreter expects, and no formal specification enforces their alignment, the operating system itself becomes the recovery mechanism of last resort. This white paper argues that formal verification and predictive telemetry make that failure mode impossible to ship. Two architectural gaps converged that morning. The first was what the paper calls the rapid response paradox. CrowdStrike's Falcon platform can push behavioral configuration files, channel files, without a full sensor update. This trades deployment velocity for validation depth. The content validator running in the cloud approved the July 19th update against the 21-field schema. The content interpreter, running in the Windows kernel at ring 0, knew only 20 fields. No runtime bounds check existed between them. The validator and the interpreter held different worldviews, and the system trusted both. The second gap was the dead agent race condition. The crash occurred so early in the boot sequence that the Falcon management agent, the component that would have received a cloud rollback command, had never initialized. Every affected endpoint was orphaned. The only recovery path was manual: boot into safe mode, navigate to the driver directory, delete the faulty file. For Delta Air Lines, that meant 40,000 servers and thousands of workstations touched by hand. Deep AI addresses both gaps through three converging architectures. The first is formal specification alignment. The paper introduces VeCoGen, a framework that combines a large language model with the ANSI/ISO C specification language known as ACSL. VeCoGen does not merely generate C code, it generates C code alongside its mathematical proof. Every function in a content interpreter carries a formal contract. This function reads exactly n input fields, where n is the value asserted in the cloud-distributed template definition. A proof checker, a deterministic verifier, confirms that contract before the binary reaches the kernel. The logic error behind channel file 291 would have failed that gate at compilation, not at runtime on 8.5 million machines. The second architecture is the AITA-framework, AI-driven telemetry analytics. Instead of static thresholds, AITA deploys three unsupervised learning algorithms in sequence: isolation forest to surface statistically rare events, dbScan for density-based separation of anomalous hardware clusters, and autoencoders trained on the established baseline of normal low-level system behavior. In a channel file 291 scenario, AITA would observe the out-of-bounds read as a hardware-level deviation within the first milliseconds of evaluation. The response is a local kill switch, isolating the faulty driver before the cascade can propagate to a second endpoint. The third layer closes the loop when the anomaly is confirmed. An agentic system performs real-time root cause analysis, tracing the causal chain from the configuration change to the memory fault, rolls back to the last known good configuration file, and generates an adaptive alert with its confidence level attached. Scale of July 19th makes these architectural arguments concrete. 8.5 million windows and points, $10 billion in global damages. U.S. Fortune 500 companies absorbed $5.4 billion of that loss, excluding Microsoft's own costs. In aviation, Delta Air Lines canceled more than 7,000 flights over 5 days, a disruption that lasted 3 to 5 times longer than American Airlines and United Airlines, which recovered within 72 hours. The divergence traced to a single architectural dependency. Delta's crew tracking system ran on Windows. When 40,000 servers crashed simultaneously, the airline had no mechanism to reposition its staff. The total loss reached $550 million in May 2025. Judge Kelly Lee Ellerb of the Fulton County Superior Court declined to dismiss Delta's claims of gross negligence and computer trespass. The court ruled that deploying to all 8.5 million endpoints simultaneously, without a canary rollout, without a staged exposure, and without a runtime bounds check, might satisfy the legal standard for gross negligence. The computer trespass claim proceeded on separate grounds. Delta had opted out of automatic updates in its settings, and the kernel-level channel file overrode that preference without authorization. On the technical side, AITA benchmarks from independent research show 97.5% precision and 96.2% recall at the anomaly boundary, alongside a 35% reduction in mean time to detect. The Delta v. CrowdStrike ruling signals an industry inflection point. The court is drawing a line between best effort software delivery, which the enterprise industry has treated as a commercial norm, and the legal standard of care that kernel-level privilege now demands. The paper frames this as the shift from gross negligence to baseline expectation. The Ring 0 safety protocol, it defines strict schema versioning between cloud validators and endpoint interpreters, boot loop simulation across diverse virtualized hardware environments, and mandatory progressive exposure rollout with defined watch windows will within a short period become the contractual minimum for any vendor touching an enterprise kernel. The AI-native enterprise does not wait for that shift to become law. It installs formal verification and predictive telemetry as the architectural floor today, before the next channel file 291 names its operations in the complaint. Read the 13-page brief, approximately 17 minutes. The paper traces the complete anatomy of channel file 291, from the out-of-bounds read that brought Ring 0 down to the VeCoGen framework that makes that class of error impossible to ship.